There's a specific part sitting on your diesel truck's frame rail right now. It costs about $40 to manufacture, and when it fails, and it will fail, it will reduce your $60,000, $80,000, or $90,000 work truck to 5 miles per hour. Not in the shop, on the road, under load, possibly with a trailer behind you. The dealer will charge you between $2,500 and $8,000 to fix it. And the federal government mandated every single piece of it. This is not a horror story. This is Tuesday for diesel truck owners across America. And today, we are going to open the hood, trace the exhaust line, and show you exactly how the DEF trap was engineered, regulated, and sold to you as progress. Before we get into the hardware, understand the legal architecture that created this problem. In December of 2000, the Environmental Protection Agency published its final rule targeting nitrogen oxide emissions from heavy-duty diesel engines. The target was 0.2 grams per brake horsepower hour. That is an 83% reduction from the prior standard of 1.2 grams, a legitimate environmental goal. Nobody argues the air is not cleaner for it, but the engineering solution the EPA mandated to hit that number was a system called Selective Catalytic Reduction, SCR for short. An SCR requires diesel exhaust fluid, DEF, 32.5% urea dissolved in deionized water. Starting in 2010, every heavy-duty diesel pickup sold in America had to have it. The Ford 6.7-liter Powerstroke, the Ram 6.7-liter Cummins, the Duramax 6.6-liter in the Silverado and Sierra 2500 and 3500, every one of them. Mandatory. They call this advanced emissions control technology. We call it a countdown timer on your truck's ability to move faster than a golf cart. Here is the system as it was designed. DEF fluid lives in a separate plastic tank made by a company called Plastic Omnium, bolted to the frame rail. An electric pump assembly, built by Bosch, pulls that fluid and atomizes it into your hot exhaust stream ahead of the SCR catalyst. The catalyst then converts nitrogen oxides into nitrogen and water vapor. That is the chemistry. It works. When it works, monitoring the system is a ceramic quality sensor inside the DEF tank itself. Its job is to verify the urea concentration stays within specification. Upstream and downstream of the SCR catalyst sit two NOx sensors built by Continental with ceramic sensing elements. Their job is to confirm the chemical conversion is actually happening. Every component in this chain communicates to the engine control module, and the engine control module talks to the EPA calibration protocol baked into your truck's software. Here is what the EPA calibration protocol does when something in that chain fails. After the first fault code, you get a warning light and a message. After repeated ignored faults across approximately 4,200 miles or 80 hours of operation, the truck enters a Phase 1 derate, 45 miles per hour maximum. If that is ignored, the truck enters Phase 2, 5 miles per hour. That is not a typo. 5 miles per hour. Your $60,000 work truck, built to haul 30,000 pounds down the interstate, is legally calibrated to crawl. This is not a defect. This is a federal mandate. The EPA requires manufacturers to program this derate into every covered diesel sold in America after 2010. The intent was to prevent owners from simply ignoring emissions failures indefinitely. The consequence is that a $40 sensor can make your truck undrivable before it reaches 100,000 miles. Now let us talk about why that $40 sensor fails. Because this is where the engineering crime lives. The DEF quality sensor is a ceramic probe suspended inside a high-density polyethylene tank. It measures the electrical properties of the fluid to verify urea concentration. When temperatures drop below 12 degrees Fahrenheit, DEF fluid expands by approximately 7% as it begins to crystallize. That expansion stresses the ceramic probe. It also drives urea crystals into the sensor housing, the pump inlet, and the pump motor bearings. At 50,000 to 90,000 miles, which is exactly the window most trucks fall into after their basic warranty expires. That pump motor seizes. The ceramic probe cracks or reads incorrectly. The NOx sensors drift from soot accumulation and thermal cycling. Fault codes P20EE and P207F begin appearing. And here is the timing that should make every diesel truck owner sit up straight. The basic bumper-to-bumper warranty on these trucks is 5 years or 100,000 miles. But the federal emissions warranty, the specific warranty that covers DEF system components, is 5 years or 100,000 miles for defects, with major emissions components covered for 8 years or 80,000 miles. The system is most likely to fail between 50,000 and 90,000 miles. When that warranty coverage runs out, the repair lands entirely on you. The NHTSA complaint database documents numerous recalls across Ford, Ram, and GM covering DEF system failures. NHTSA complaint record ODI number 10136079 documents a 2023 Ford F-350 entering a full derate for a DEF pump failure. That is one record among thousands. Cummins reached a major settlement in 2023 involving emission system violations. Ford has faced warranty breach litigation over DEF system claims. GM has faced similar class action exposure. These are not corner case complaints from a handful of unlucky owners. This is a documented, litigated, federally recalled pattern of system failure. And the failure is not random. A 2023 whistleblower report from inside Cummins alleged that NOx sensor calibration testing was being skipped during production. The report estimated 5 to 10% of engines may have shipped with uncalibrated sensors. An OSHA citation issued to Ford's Louisville assembly plant in 2024 documented wiring faults in the DEF harness assembly. The inline production scanner was not catching them because the test protocol only covered fuel and ignition circuits. At 200 trucks per day, with a 20 to 30-minute production window per unit, these are not surprises. These are the mathematics of speed over precision. The DEF pump assembly itself comes from Bosch, manufactured in Mexico and Germany. The NOx sensors come from Continental, with some production in China. The DEF tank is among the more domestically sourced components made by Plastic Omnium in Tennessee. You are paying $90,000 for a truck that cannot move without an imported ceramic sensor clearing its federal compliance report every time you turn the key. But the manufacturing quality is only half the trap. The repair trap is the other half. When your truck enters limp mode, you cannot simply clear the fault code yourself. Not on a post-2018 heavy diesel. Cummins uses a proprietary diagnostic platform called Insight. Ford uses IDS. A subscription to Cummins Insight costs around $500 per year. Purchasing the full diagnostic equipment independently costs more than $10,000. Without those tools, a DEF-related fault code that triggers derate cannot be cleared by any independent shop that has not made that investment. The dealer charges $150 per hour minimum. A DEF sensor replacement runs $800 to $1,200 at the dealer for parts alone. Add 1 to 2 hours of labor. A DEF pump replacement runs $1,500 to $3,000 for the assembly plus labor. A full system failure involving pump, sensor, and NOx sensor simultaneously, which happens, and the NHTSA data confirms it happens, runs between $2,500 and $8,000 on a truck that is still being financed. The new truck pricing range for a mid-range heavy-duty diesel in 2025 is $50,000 to $90,000. Depreciation on these trucks is severe precisely because the market knows what the DEF system costs to maintain. Meanwhile, pre-2010 diesel trucks that carry none of this emissions hardware depreciate more slowly because experienced buyers understand their long-term ownership cost is dramatically lower. Here's the only math that matters. You financed an $80,000 diesel truck for 84 months. Your monthly payment is over $1,100. At 60,000 miles, your DEF pump seizes. The dealer quotes you $4,000 to repair it. You still owe more than $50,000 on the loan. The truck is worth $32,000 on the open market. You are $38,000 underwater, and your truck is in limp mode in the dealer's service bay. Now, does that mean you give up on a diesel truck? No. It means you stop buying the emission system and start buying the engine. The pre-2010 Cummins 6.7 is actually a solid block. The problem is the federal plumbing bolted to it after 2010. Go back further. The 5.9-liter Cummins, specifically the 12-valve version found in Dodge Rams from 1994 through 1998, is a cast iron block, mechanical injection, no ESUM-DEF, no SCR, no DPF, no electronics beyond the basics. Mechanics call it the 12-valve, and they call it that with respect. It has no limp mode protocol because it has no federal compliance computer, measuring its exhaust chemistry every 30 seconds. It runs on clean diesel and mechanical precision. 200,000 miles on these engines is unremarkable. 300,000 is common. There are verified examples north of 500,000 miles with original bottom ends. The 1998.5 through 2007 24-valve Cummins and the Ram 2500 and 3500 is a reasonable second choice. It added electronic injection but still predates the SCR mandate. DEF-free. EGR can be deleted cleanly. DPF equipped only in the final years, and those are avoidable if you target 2007 and earlier. The 7.3-liter Powerstroke in the Ford F-250 and F-350 from 1994 through 2003 is what Ford people call the bulletproof 7.3. Direct injection through a high-pressure oil-actuated system. Cast iron everything. No DEF, no SCR, no variable geometry turbo to fail. The HEUI injection system is its one known weakness. High-pressure oil actuates the injectors, and the oil pressure regulator wears over time. But that repair is a $500 job a competent independent shop can handle. Compare that to a $4,000 DEF system failure on a truck that is still underwater. The early 6.6-liter Duramax in the first and second generation, specifically the LB7 and the LLY from 2001 through 2006, is a cast iron block diesel V8 with legitimate longevity credentials. The LB7 injectors are a known failure point and an expensive one, but no DEF, no SCR, no limp mode calibration tied to a urea sensor. When you go looking for any of these trucks, here is what to check. Pull every fault code before you negotiate. If the seller does not have a scanner or will not let you run one, walk away. Look for white crystalline deposits around the DEF tank and exhaust piping on any post-2010 truck. That is evidence of prior DEF system failure. On a used pre-2010 diesel, check the frame behind the rear axle for perforation rust, particularly on northern trucks. Pull the engine oil and look for white emulsification. That is coolant intrusion, and it is a disqualifier. Smell the exhaust at idle. Excessive blue smoke on a diesel is turbo seal failure. Excessive black smoke at idle is injector wear. The price difference is real. A clean 2002 Ford F-250 with the 7.3 Powerstroke in good mechanical condition trades between $12,000 and $22,000 depending on mileage and condition. A 2005 Ram 2500 with the 5.9 Cummins in solid shape is in the same range. Your annual payment on a $20,000 truck at current interest rates over 4 years is less than $500 a month. There is no DEF system to fail. There is no limp mode protocol waiting at 60,000 miles. There is no proprietary diagnostic system requiring a $10,000 scanner to clear a fault code. Stop financing emission systems. Start buying proven cast iron. The diesel truck you are making payments on right now is not broken. It is working exactly as designed. It is designed to fail at a specific interval, require a specific dealer tool to diagnose, and cost a specific amount to repair, all within a legal framework that prevents you from fixing it yourself or bypassing the system that caused the failure. Every component in that chain was mandated by regulation, assembled under production speed incentives, and covered by a warranty timed to expire before the statistically likely failure window. That is not conspiracy. That is engineering economics backed by federal recalls and hundreds of millions of dollars in litigation over emission system failures. Buy the iron. Own the machine. Keep the wrench in your hand.